Betelgeuse, a red supergiant star, is a fascinating celestial object. If placed in the position of our Sun, its immense size would extend to the orbit of Jupiter, making it one of the largest stars known. Its unstable nature has led scientists to believe that it might soon explode in a supernova, which would be one of the most powerful bursts of energy in the universe, releasing more energy than a billion suns. Betelgeuse stands out not only for its massive size but also for its distinct orange color, making it one of the brightest and most noticeable stars in the night sky. Unlike many stars that maintain consistent brightness, Betelgeuse is classified as a variable star, meaning its brightness fluctuates over time. Sometimes it shines so brightly that it outshines even the most luminous stars, such as Sirius, capturing the interest of both amateur and professional astronomers. Over the years, scientists have speculated whether Betelgeuse is on the verge of a catastrophic explosion, a supernova. While this might sound alarming, astronomers are eagerly awaiting such an event, as it would provide valuable insights into the life cycle of stars. If Betelgeuse replaced our Sun, its massive circumference would extend beyond Mars' orbit and even into the asteroid belt. Despite this staggering size, there's no immediate threat to Earth, as Betelgeuse is located at a comfortable distance of about 642 light-years from our planet. In cosmic terms, this distance is relatively close, especially considering that Betelgeuse is the nearest star to Earth that is expected to end its life in a supernova. According to astrophysicist Neil deGrasse Tyson, the variability in a star's brightness can be influenced by several factors, such as size, temperature, and distance from Earth. For instance, stars like Rigel and Aldebaran, though both bright, experience fluctuations in their luminosity. This variability gives astronomers clues about a star's life cycle and its eventual fate. In recent years, Betelgeuse has undergone significant changes in brightness, particularly in the past 5 years, sparking the curiosity of astronomers and space enthusiasts. The name Betelgeuse itself has a rich linguistic history, tracing its origins back to Arabic. While scholars debate the exact meaning, the current usage is widely accepted as the most appropriate for describing this iconic star. Betelgeuse belongs to the red supergiant category, one of the largest and most massive types of stars in the universe. Located in the constellation Orion, Betelgeuse is easily identifiable due to the distinct arrangement of stars in the constellation. While far enough from Earth to pose no immediate threat, Betelgeuse is still close enough to be a focal point of astronomical study. Advanced instruments, such as the Hipparcos astrometric satellite, have allowed scientists to measure distances to celestial objects with precision. Through this technology, it has been determined that Betelgeuse is approximately 642 light-years away from Earth. Understanding these vast distances helps put the size of our universe into perspective, reminding us of how far apart stars and galaxies are from one another. One of Betelgeuse's defining characteristics is its variability. Its apparent magnitude, a measure of its brightness as seen from Earth, ranges between 0.0 and 1.6, indicating significant fluctuations in brightness. In the Bayer designation system, which classifies stars within constellations, Betelgeuse is known as Alpha Orionis, indicating its prominence in the constellation Orion. Sometimes, Betelgeuse outshines Rigel, Orion's other bright star, due to its unpredictable changes in brightness. Historical records show that 17th-century astronomer Johann Bayer gave Betelgeuse its name in his 1603 publication, where he also named Rigel as Beta Orionis. Despite its prominence, Betelgeuse stands alone, unconnected to any larger star formation or cluster, unlike stars that form in dense regions of gas and dust. Betelgeuse is considered a runaway star, meaning it has been ejected from its original location and is moving through space at high speed. With a radius over 900 times larger than the Sun and a mass 16.5 times greater, Betelgeuse is truly a giant among stars. Despite its massive size, it is cooler than the Sun, with a surface temperature of 3,600 Kelvin compared to the Sun's 5,778 Kelvin. However, its luminosity is astonishing, shining with a brightness over 100,000 times greater than that of the Sun. Though Betelgeuse is approximately 642 light-years away, it is considered a relatively young star, estimated to be around 10 million years old. In comparison, our Sun is middle-aged at roughly 4.6 billion years. Despite its youth, Betelgeuse is nearing the end of its life as a red supergiant, having already exhausted much of its nuclear fuel. Its final act will be to explode in a supernova, releasing an incredible amount of energy. When Betelgeuse finally goes supernova, the explosion will produce as much light as an entire galaxy, outshining everything around it. While the event would be spectacular to observe from Earth, anything within a few hundred light-years of the blast would likely face devastating consequences. However, at Betelgeuse's current distance from Earth, a supernova would not pose a direct threat to our planet. The study of Betelgeuse offers astronomers a rare opportunity to witness the life cycle of a massive star and the processes leading up to a supernova. As we continue to observe the changes in Betelgeuse's brightness and behavior, we gain a deeper understanding of the universe and our place within it. There hasn't been a supernova visible in our solar system since 1604, though astronomers observed one in the Large Magellanic Cloud in 1987. This event took place 169,000 light-years from Earth, but it still had a noticeable impact, showcasing the far-reaching effects of cosmic explosions. When a star goes supernova, it leaves behind remnants, which are the leftover material from the explosion. A well-known example is the object G292.0 plus 1.8, a remnant from a long-ago supernova. These remnants are intriguing, often containing high concentrations of oxygen and other elements. The Large Magellanic Cloud, where the 1987 supernova occurred, is far enough from Earth to pose no threat, but it serves as a reminder of the immense forces at work in the universe. If a supernova were to occur closer to us, within 100 light-years, it could have significant consequences. Stars like Alpha Centauri, which lie within this range, could pose a potential threat if they were to explode. However, Betelgeuse, while relatively close, is still beyond this danger zone, meaning we are not in immediate peril from its potential supernova. Nevertheless, scientists are closely monitoring Betelgeuse due to its unpredictable nature, which makes it a star of great interest. The question on many minds is whether Betelgeuse has already exploded. As the closest red supergiant to Earth, it's the most likely candidate for a near-future supernova. In late 2019, Betelgeuse experienced significant and unexpected dimming, leading to speculation. Some believed this dimming was a sign that Betelgeuse was on the verge of exploding, as such behavior can sometimes precede a supernova. The dramatic drop in brightness caused concern among both scientists and the public. However, despite the initial alarm, Betelgeuse has since regained much of its brightness and appears to be in a more stable state for now. While its eventual explosion may not be imminent, Betelgeuse remains a subject of intense observation by astronomers. Betelgeuse, with its distinctive reddish hue, is a familiar sight in the night sky, especially during winter months. Its position in the constellation Orion makes it easily recognizable to stargazers. Thanks to observations made by NASA's Hubble Space Telescope and ground-based observatories, astronomers have gathered valuable data about Betelgeuse's behavior. In 2019, the star experienced a massive surface mass ejection, during which a portion of its outer layers was expelled. This event caused the dimming seen from Earth. Surface mass ejections are similar to coronal mass ejections, CMEs, that occur on the Sun, where part of the Sun's outer atmosphere is ejected into space. However, the mass ejection from Betelgeuse was on a much larger scale, ejecting 400 billion times more material than a typical CME from the Sun. This massive cloud of gas temporarily blocked some of Betelgeuse's light, leading to the dramatic dimming visible from Earth. Earlier estimates placed Betelgeuse farther from Earth, but recent measurements suggest it could be as close as 724 light-years away. Measuring the distances of red supergiant stars like Betelgeuse is challenging for astronomers, as these stars are often surrounded by clouds of gas and dust that obscure accurate measurements. Despite uncertainties about its exact distance, Betelgeuse remains one of the brightest stars in the night sky. Its tremendous energy output, about 100,000 times greater than the Sun's, is accelerating the process of fuel depletion within the star, bringing it closer to its inevitable end. As Betelgeuse continues to evolve, inching toward its final supernova, astronomers are closely watching, eager to learn more about the life cycle of stars. Betelgeuse, also known as Alpha Orionis, has captured humanity's imagination for centuries. Its prominent position in the constellation Orion has made it a key reference point for both sailors and stargazers alike. The star's name comes from the Arabic phrase Betelgeuse, meaning the giant's shoulder, highlighting its historical significance across cultures. In addition to its impressive size and brightness, Betelgeuse exhibits fascinating characteristics that make it a unique object of study. One such feature is its pulsating nature. Researchers have identified that Betelgeuse undergoes periodic changes in brightness, driven by its outer layers expanding and contracting. This behavior is often attributed to complex interactions within the star's atmosphere, influenced by convection currents and pulsational instabilities. These pulsations can last anywhere from a few weeks to several months, adding to the star's variability. Interestingly, Betelgeuse may not be a solitary star. It could be part of a binary system. Some evidence suggests that Betelgeuse might have a companion star, which could influence its evolution over time. The gravitational interaction between these stars might play a role in the shedding of material from Betelgeuse's outer layers, contributing to the brightness changes observed by astronomers. The potential presence of a companion star adds another layer of intrigue to the study of this red supergiant. Betelgeuse's enormous energy output has implications for its surrounding environment as well. The intense radiation and stellar winds produced by the star can significantly affect nearby cosmic structures, such as the Orion Nebula. This region is a stellar nursery where new stars are born, and the influence of a nearby supergiant like Betelgeuse could trigger the formation of new stars or alter the course of existing ones. Astronomers continue to study these interactions to better understand how massive stars shape their surroundings. Another captivating aspect of Betelgeuse is its stellar life cycle. As a red supergiant, Betelgeuse has evolved from a main sequence star, during which it fused hydrogen into helium over millions of years. As the hydrogen in its core was depleted, it transitioned to fusing helium into heavier elements like carbon and oxygen. This process continues until the star reaches the iron stage, at which point fusion stops, leading to its catastrophic collapse and eventual supernova. Understanding this evolutionary pathway has helped scientists piece together the life cycle of massive stars, which ultimately enrich the interstellar medium with heavy elements upon their death. Studying Betelgeuse also provides insights into the phenomenon of gamma-ray bursts, GRBs, some of the most energetic events in the universe. While Betelgeuse is not expected to produce a GRB, studying its characteristics and eventual supernova could offer clues about the conditions under which such explosive events occur. GRBs are thought to result from the collapse of massive stars and are among the brightest explosions observed, with the potential to outshine entire galaxies for brief periods. Beyond its scientific significance, Betelgeuse has permeated popular culture, inspiring numerous references in literature, films, and music. The star's distinctive name even led to the title of the famous Tim Burton film Beetlejuice, demonstrating how celestial objects can capture the public's imagination. These cultural connections underscore the star's appeal beyond the realm of science, drawing interest from a broader audience.